I was asked by the department over this past year to lead a committee of scientists and socioeconomists to discuss ways of measuring resilience change for a number of projects that the DOI has already funded. So this is a slightly different talk from the one you just saw, in that we have projects that are already funded, that are currently ongoing or are actually ending, and DOI is asking us to figure out how to measure their success. So we're talking about climate change on the coast. The big issues related to climate change are going to be sea level rise, of course, and we've got sea level rise happening actually faster in the southern part of the northeast coast, down around Norfolk, Virginia, et cetera, than happening in the north. So sea level rise is not consistent. It's not a bathtub. We've got subsidence going on down in the south, and that's affecting the conditions that we're having to deal with. We also have warming going on in the ocean. Actually, the Gulf of Maine is warming faster than just about anywhere else on the planet. That's a result of interactions between the Labrador Current and the Gulf Stream, and that has actually affected policy because the cod fishery is collapsing, really to a number of reasons related to this warming, and our policy did not include warming of the ocean in deciding the number of fish they could catch each year, and so we started overfishing relative to the circumstances. So it's an important example of the link of science and policy and how we have to be tracking these things in order to avoid making mistakes. The big issue that I'm going to talk about today is storms. Storm surge and waves, the effect of storms and how they're changing on the northeast coast. Hurricane Sandy happened in 2012, very late in the fall. It damaged a lot of the coast for 12 states, the District of Columbia, and the Interior Department received a lot of money through a congressional grant to both deal with rebuilding of federal infrastructure and also to help communities, and thirdly, to try to get a handle on how to improve the resilience of the coast. So about $340 million were used for understanding and improving coastal resilience. At the same time, the Federal Disaster Recovery Coordination Plan was written, and they asked for quantifying benefits of resilience projects and calculating resilience project return on investment in order to better inform future public spending. This report and this mandate was written around the same time that we were funding all of these 140 projects. So we had a number of projects, and DOI needed to figure out how to measure regional resilience change relative to the projects that they ran. A number of us complained that this was a tough thing to do because we didn't have the baseline information. We actually didn't even know what to measure. And many of these projects were funded without coaching them as to what kind of measurements we would want to have made as part of their projects. And the reward I got was to be asked to chair a committee to figure out how to do that. So we formed a committee to assess, we basically need to assess resilience change. We wanted resilient coastal systems, but this is all stuff that we've discussed today, so I really don't need to go through it. Big important one is that the baseline conditions were very poorly documented and were not consistently documented from project to project location. So a lot of great science and great socioeconomics and great restoration work was actually going on, though, and really useful information. This shows the expansion of our LiDAR coverages for the East Coast. So it's actually nearshore bathymetry and the topography of the coast. Very fine resolution. This makes a huge difference for figuring out where places are going to inundate first, where we are most vulnerable, where we would want to spend our first resources to try to bolster those areas or maybe move people out of those areas so they are no longer threatened. And hugely important actually to all the other projects that were going on in the coastal zone. Impacts on beaches and barrier islands. Thinking about wave and surge effects, you see this beach that was strongly damaged during Hurricane Sandy. Wave and surge over top of the dunes, and looking at inundation rates, development of breaches. There's big controversy about whether to fill breaches in or whether to leave them after they form. And most importantly, I think in all of this is where are the tipping points and the controlling processes that trigger these changes? Because if we don't understand those, then we really can't build a system that we can say with confidence is resilient, because we don't know what we're facing in the future. The swath network, it's surge, wave, and tide hydrodynamics. These are real-time instruments that are, are normal instruments where we're measuring tides, and NOAA has a number of tide gauges. We've added a few to their network. They're measuring, say, about every 15 minutes the depth of water at the tide gauge. We're talking about instruments that are measuring 4 beats a second. So they're actually catching the wave crests as they're coming by. And these things are installed. We've installed stations all along the East Coast where we can just take the instrument, slap it into place, and move on to the next. There's like 650 sites now, I think, along the East Coast where we can do that. The reason was to be able to get them out fast. We wait until we know what the trajectory of the storm is, send out SWAT teams to go out and put these things in place. Some of them have radio telemetry, so we're giving real-time data to early responders now. So you know where the surge and wave is occurring early enough to get people out of harm's way. Another link to the socioeconomic issues. Contamination. It's one thing to have our houses inundated with water and then have the water recede. It's another thing if it's also carrying away the gas can we have in the garage, the orthochemicals that people use in the gardens, and all of the other toxic wastes that are actually in the coastal zone, the sewage treatment plants, et cetera. And so we've developed a network of contamination sites looking at sources, sinks, the pathways, how these things get released. Real-time coastal erosion. This is a great tool that's developed where we are looking at what I just showed you on the other slide, actually, the collision, the inundation, et cetera, and the risk of these things happening. The authors of this work took the new LiDAR, they took the new surge data, and they built a model. It very accurately predicted the Fire Island breach that occurred, and it's telling us now in fairly minute detail what parts of the coast are most vulnerable to surge and wave. This model has already been applied to Hurricane Joaquin. And we found with that application that many of the places that we say were vulnerable, gone back and shot them with aerial photography, and found that indeed some of the beaches that we replenished after Hurricane Sandy in order to rebuild the beach and restore the tourism industry there were now washed out again and needing to be replaced. So this kind of information is extremely valuable from the perspective of having an economically viable tourism industry for those beaches. There's work on urban systems, the Jamaica Bay work that Adam, you're going to, wherever Adam is, yeah, going to mention later on in the week. Other urban projects. There's 145 projects total that were funded, and Marsh Restoration work, where there's 14 marshes the Fish and Wildlife Service is restoring, several more that projects funded external to the federal government through the National Fish and Wildlife Foundation are also working on restoration projects. And so very strong work looking at resilience change within these marshes and whether or not they can keep up with sea level rise with the thin layer deposition concepts, things like that. And finally, many projects related to helping communities deal with risk. Everything from helping them design green infrastructure to planning to education programs. This is one example in the city of Norfolk. I ran through these just to show that there's a lot of really good, useful information that's being generated. The problem is they're discrete projects, and pulling them together to answer regional questions is really the challenge. So the DOI formed this expert group. As I said, we were charged with establishing a core set of metrics, establishing what baseline and data and science gaps there were that would make a overall assessment of regional resilience difficult. linking metrics across the subregions, leveraging our current and historical measurements, because if we don't have a long-term record, it's very difficult to see trends and to see whether or not resilience can be improved. And trying to establish consistent metrics, not only among the projects, but among other programs within the federal government, states, NGOs, so that we are able to take advantage of a wide array of data to look across the region and determine how resilience is changing. So we had our definitions. This is the definition from the executive order. It's in our report on the metrics recommendations. Frankly, we didn't spend a lot of time after dealing with that after it was decided. We mainly focused on the metrics, core metrics being a set of performance metrics that are applied to multiple projects for a full range of temporal and spatial scales, and that represent a change in resilience in one or more of coastal features. Performance metrics being a larger set of other metrics that you could use, but we wanted to try to get towards a core set that we were trying to apply across similar systems. We divided the coast up into different coastal features. You see beach systems, near-shore shallow, upland watersheds, green infrastructure, living shorelines, because we had a lot of projects focusing on that, and then other types of green infrastructure. The point being that for a rigorous assessment, we felt that we needed to get specific, because these different features required specific kinds of measurements in order to detect a change. And this is just an example of some of the metrics we came up with. As Igor says, we always start with laundry lists of metrics. The trick is to try to wean those down to a few that we can actually use across space and time and across different programs, and that's what we're in the process of doing now. But you can see that actually we have filled a number of the spaces in the analysis that we were doing with different kinds of projects. Again, the challenge here is linking the information from these projects so we can say something more broadly about regional resilience change in the Northeast. This is a figure from the ABT consulting report that just was delivered to us about a week ago, where they're trying to sort out what socioeconomic metrics we could develop. They focused in on those because we felt like we were even weaker there than we were with the environmental metrics. The big challenge now is to link our environmental metrics and our socioeconomic metrics, which is one of the primary things I'm hoping to discuss while I'm at the meeting.
Number of indicators, or what are the numbers?
There's a number of projects that we had that were dealing with these different issues and the different socioeconomic strata that they had for their analysis. And I can talk to you in more detail about that later. It's a long, lengthy report, a lot of good detail. They came away from with their preliminary report saying to us that they really didn't know how to link science and socioeconomics. And so we're now jumping back into that next week. Yes, well.
Don't forget, don't keep it hidden.
Right. Finally, testing synthesis. We have a number of locations where we're trying to do this. Jamaica Bay, as I described, I think that, there's a number of great projects that are being integrated to look at whole systems. We're trying the same thing at Forsyth National Wildlife Refuge, trying to see if we can get at a national strategy for assessing wetland change. What do we mainly need here? Is one of the things that we were asked about. And Igor was asking me. We need puzzle makers. We need the people who not only know how to build the components of these questions, but can actually do the deeper thinking of how we start to link them together. And so I'll leave it at that.
Great, thank you. Questions? Thanks very much. That was excellent.
In terms of the survivability of the physical space itself, what about other infrastructures there? So transportation, water, other factors that would be affected for
those
the population?
Those are included in several of the socioeconomic studies that were funded, and so they are part of this. And we're also trying to do that primarily through collaborations with our sister federal agencies that are more focused on those things, like the Department of Transportation.
Pete, during the broader discussion,
Yep.
put up the challenges, right?
Okay.
Right? So
Great.
then we can entertain some of them. What was the order of business? I know I stopped somewhere. You, and then Igor, Roger, then.
So you mentioned thresholds, but then in terms of the metrics, you're mostly talking about trends, and I didn't see metrics for thresholds.
right.
And so maybe just to clarify, are you exploring modeling of thresholds? How are you kind of
Correct, yeah, modeling, but, yes, basically, it's, you know, it's a, there are data that allow us to see some thresholds in some features that, you know, because of work that's already been done. But we feel this is absolutely critical, that if we don't know where the thresholds for going into a next state change are, then we can't define resilience in any real way. And so there's a number of researchers that are within the program that have dealt with threshold research in the past, and they're going to be helping us develop that. Yeah.
Roger, then you.
I'll make it quick. So in the socioeconomic metrics, you have a bunch of sectors, socioeconomic sectors. How do you know they have any effect on resilience?
That was my question.
Well, resilience of it depends on what you're asking. Resilience of the community. We certainly have information that allows us to say that you know that like programs that are more effective at dealing with health and safety issues during events, storms, will help the health and safety of that community. But to be honest, that's our question as well. It's a work in progress. And so we want to we just want to get started and take a crack at it, basically. And that's what this is about.
This is a fundamental issue, right? We're playing certain interventions lead to certain outcomes. We want to ask that question as to how do we know. Sir.
Yeah, maybe just a comment on the socioeconomic matrices. We've done a lot of work in that, and if you determine your indicators, turn them into an index, and rank or score each one of those indexes or indicators against each other to see what impact they're having. Have you heard of the Pearson's correlation coefficient?
Right.
If you use that, it's really, really helpful. So that was just a comment on that. And then secondly, I was very taken by your work on the Marsh Restoration. We have in Europe, we have an EU directive called the Habitats Directive.
Yep.
Have you heard that? It came in '92. And one thing they're trying to promote is habitat restoration. And they're finding it very difficult to measure that. So I think your tool.
Well, that's one of the things we're really going to focus on.
Really
Yeah.
interesting
And also the
European
question is,
context.
there's a big question of time in this as well. You know, because if we are wanting to restore, to basically maintain a wetland for the next 150 years, there are places where it's just not going to happen. If we need it for 50 years in order to preserve a species and give us time to find another way to get a flyway for that species, then we can do that.
So you're framing a timeline.
Right.
Condition,
So
right?
time is
What
part of the
allows-
resilience
what
protocols.
allows holding off a decision, right? Time
Right.
to think is pretty.
Time to
critical,
think.
Right?
Yeah.
So I want to get some of that.
I'm really interested in the stationarity question, and maybe, hopefully, we can discuss it in a little more depth in
Right.
a little bit. I wonder, it seems to me that a lot of our responses to these non-stationary problems are very stationary.
Yes.
Can you give
Very good.
examples of non-stationary responses to this kind of issues you're talking about?
Marsh migration, creating migration corridors so the marsh can move inland. What they call managed retreat, which is a polite way of saying you're going to lose your house. Right? Yeah. Those are the kinds of things.
Yeah. This is a great question, right? Because we're talking about cross time scales of everything, climate included, and the adaptations and adjustments are themselves. They have a temporal and spatial dimension. We'll come back. I want to come back to that question on indicators. Thank you very much.